Okay, you're going to be learning what's called Euler's method. This E-U-L-E, that stands for Euler's. It's not Euler's. He came up with a lot of stuff. If you took discrete math, there is something that Euler did with Euler circuits. And then there's other things that he's done before. This method is a method that will help you to be able to approximate the value of a function knowing the slope. So here's a graph, and just to kind of explain where this is coming from, and I know some of you are not worried where it's coming from, but I'm going to show you anyway. Let's say that this was the original graph. What you do is you start at a certain place, like you start here, and you use the fact that the slope is, I don't know, maybe 1/2. And you add that to make a new line, and you find a new y value. Then you use the slope of the next part, and you find a new y value. So every time, it's almost like you're constructing this without knowing it. So, like maybe the slope next time is 1/4. So you have to draw it a little bit smaller, and then you have a new y value. And every time you just continue with the slope, and eventually you can approximate what the y value is. Why do you need to know this? Because it's part of AP Calculus. It's another one of those things that you just kind of need to memorize the process, because they might say use Euler's method to approximate the solution. There's not any like really weird kind of problems that they'll do with it, but they'll always say use Euler's method. So first of all, the way that I do Euler's method is I have this sort of table memorized. You start off with what x and y are, then you find the slope, then you write the equation of the tangent line, and then there's something called next x and next y. And that's, I'm right here on the edge. It keeps trying to move it for me. So that's sort of the table that you memorize, and that's what you're going to need in order to approximate the solution. So let's say that you have a problem, and what it says is that y prime equals x plus y. It tells you that we're going to start at the point 0, 1, and it tells you that they want the change in x to equal 0.1, and they want to know what y of 0.3 is. They want you to approximate y of 0.3. Okay, the change in x is 0.1. That tells you how much to go up every time. So if I'm starting at 0 and I'm trying to get to 0.3, that means that I'm going to go to 0.1, then I'm going to go to 0.2, and then I'm going to go to 0.3. That is something called 3 steps. Sometimes they might, instead of telling you like to go up by 0.1, they might say go 3 steps and solve this using 3 steps. So it just depends. Alright, so we start off with the point that it gives me. Alright, it gives me the 0, 1, that's what I start off with. Then I find the slope at 0, 1, and I do that by using the y prime that they give me. So I plug in the 0, I plug in the 1, and I get 1 for the slope. Then I write the equation of the tangent line. You can write the equation however you would like, but I'm going to use point slope formula because I think it's easier to solve what you need to solve in the problem. In case you don't remember point slope formula, it's y minus y1 equals m times x minus x1. And you fill in the m, and you fill in the x1, and you fill in the y1. So on this first one, the tangent line is y minus y1 equals m times x minus x1. All I did is fill in the 0, the 1, and the 1. Alright, the next x, I get that from how much we're going up, or how much the next steps are. Starting with the x of 0, I know that I'm going up by 0.1, so my next x is 0.1. Then I plug that 0.1 in for x right there, and I solve for y. So I've got 0.1 minus 0, that's 0.1, times 1 is 0.1, and then I add 1, so because I'm looking for y. So I have to add this 1 over after I plug it in, and I get 1.1. Now you continue the process with 0.1 and 1.1 as your x and your y. Your slope, you plug in the 1 and the 0.1 up there for x plus y. It comes out to be 1.2 because I'm plugging it in up here. Then I write my equation, y minus y1 equals m times x minus x1. My next x, I go up 0.1 again, is 0.2. And I plug 0.2 into that equation. So I'll have 0.2 minus 1 times 1.2 plus 1.1 because I'm trying to solve for y. And I get 1.22. Okay, then I do it again. I do it until I get to the value I'm looking for. So I'm going to 0.2, 1.22. Plug that in for x and y. For the slope, you get 1.42. Y minus y1 equals m times x minus x1. The next x, again, I'm going up by 0.3 or 0.1 every time. Every time you just go up by how much ever you decided that you needed to. Plug in your 0.3 for x, 0.3 minus 0.2 times 1.42 plus 1.22, you get 1.362, and that is the answer. Because the problem said for you to approximate y of 0.3. That means figure out what the y value is at 0.3. We're going to estimate that it's 1.362. So anytime they say use Euler's method, this is the process. You write out this table, you fill in the information you know, and then you just solve it. And then once you get to the point that it's asking, that's the answer. Okay, here's another problem. Similar kind of problem. This time they still give you another point, and it happens to be the same point. It will not always be the same point. It just happens to be here. So they tell you 0, 1 is the point that it goes through. We know that dy dx is 2x. They're telling you that's the slope. And then they tell you, they want you to do Euler's method for 2 steps. And then they want you to do Euler's method for 4 steps. So this is 2 different problems. And then what they want you to do is they want you to find the error in the solution. So they want you to see how good the solution is. Okay, so there's really 3 parts to this question. We're going to start with the first part. Oh, and they tell you that they want you to approximate if x is 1, what is y? Now, the first part is to figure out how much we're going up by. Since it's 2 steps, and we're starting at 0, and we're trying to get to 1, that means you're going to go up by a half, because 0 to half would be 1 step, and then a half to 1 would be the second step. So we're going to go up by a half. If I do the 4 steps and I'm trying to get to 1, that means that I'm going to go up by 0.25. Because if I go up by 0.25, then I'll be going up by a half every time, and that will take it 4 times to get to 1. Alright, so I start off with this table. And we're going to do the 2 steps first. 0, 1. The slope is the 2x. So I'm just plugging in x in there. You don't have to plug in the y because it's just 2x. That's what they tell you dy dx is. So then your line is y minus y1 equals m times x minus x1. You don't have to write all that stuff with the 0, but it doesn't hurt anything. Your next x, we've already figured out we're going up by 0.5, so there's 0.5. You plug in the 0.5 here. All of that's 0, so you add 1, so 1 is your new y. Alright, then you bring that down, 0.5 and 1. Okay, to find the slope, I'm going to plug 0.5 in for x, so you get 1 for the slope. So y minus y1 equals m times x minus x1. And then if I add 0.5 to go up one more time, I get 1. This is 2 steps. Plug in the 1. 1 minus a half is a half. A half times 1 is 1. Add 1, so I get 1.5. And that's my approximation after 2 steps. Okay, let's say it said 4 steps. So I still start with 0 and 1. The slope is still 2x, so plug in that 0, you get 0. Your tangent line y minus y1 equals m times x minus x1. Then your new x and your new y. Your new x, since we're going up by 4 steps, is going to be 0.25. Your new y is 1 because you plug the 0.25 in here and then you add 1. I'm going to go ahead and fill in this table real quickly, but I think that you can do it. There's the x and the y. 0.25 times 2 is 0.5. Y minus y1 equals m times x minus x1. You know what? I didn't even do the m right. M times x minus x1. Your new x is 0.5. Plug in your 0.5 and you should get 1.125. So that comes here. That's your new things that you're plugging in. Plug in your 0.5 into 2x, you get 1 for the slope. There's your line. Your new x, go up by the same amount, is 0.75. Plug that in, you should get 1.375. We're almost done. It's a little cumbersome, but really not difficult. To plug in the 0.75, you get 1.5. New x is 1, and so now we have 1.75, and 1.75 is our approximation. Now the last part said to figure out what the error is. This particular problem gave you dy dx equals 2x. To figure out the error, what you have to do is you have to figure out what y is exactly. And we do this kind of what we did before Christmas, where you did differential equations, like you cross multiply. You won't have to do this often, but I'm just showing it to you. Take the integral on both sides. They gave us a point of 0, 1 at the beginning, so plug in that point. So you have the y equals x squared plus 1. This is the actual equation. And since we're trying to approximate y of 1, you can plug a 1 in here. This is the exact amount. It's 2. So the error here is 0.5 because we're 0.5 away of what it's supposed to be. The error here is 0.25 because we're 0.25 away of where it's supposed to be. And notice the more steps that you do, the closer you're going to get to getting the correct answer. Okay, last kind of question I want to show you real quick. They might not give you all of that information. They might just say, okay, here's a table with some slopes and some y equals, and they might want you to estimate something. So let's say we have this 2, 4, 6. The slopes are a half, a third, and 0.3, and the original y value is 1. And they tell you that we want you to do a change of x being 2 and figure out what f of 6 is, approximate f of 6. So I don't have to plug anything into a formula. I still have the same table. And I plug in the 2 and the 1 from the x and the y. The 1/2 is the slope that goes here. So then I have y minus y1 equals m times x minus x1. Since our change in x is 2, that means, and I started with 2, my new x is going to be 4. Plug in your 4 here. 4 minus 2 is 2. 2 times a half is 1. Add 1, you get 2. Your slope is a third. There's nothing to plug it in. You just use the information they give you. There's your equation. Your new x is going to be 6. Plug in your 6, you get 8/3. And that is your approximation. If they said find f of 8, then you would go one more time. Alright, 2 problems for you to try. Do them on a separate sheet of paper. So here's your dy dx. There's a point to start with, and we want you to approximate y of 4 in 2 steps. That means you're going to go up by 1 every time. And then on this one, it'll be kind of like the last one where they gave us a table. And we want to approximate y of 16 with 3 steps. If that's 3 steps, that means we're going up by 4. And so the information in the table, we'll get that from writing out the table. And that's all. See you tomorrow.